in main, we've got three things being put into our ELF file. We've got our square, which is the extern int. We've got our int x, which is which doesn't have a value set right now. It's uninitialized. And then we've got our function main. So there are a couple patterns here. In any ELF file, what you're going to do is you're going to put any function that's defined in the .text section. And as far as the defined versus undefined goes, that's going to always be defined. For any variable that is a global variable that is initialized, it's going to go in the .data section. It will also always be defined. Any variable that is uninitialized, so in this example, the main, the int x, that's an uninitialized variable, so there's no value attached to it right now. That's going to go in the .bss section, and it's also going to be defined. The only thing that's going to be undefined are those x terms. So that very first one, the x term square, that's going to be undefined, and it doesn't go in a section. It just kind of sits there. Yeah. What variables don't go in this a section? Yeah, so the only thing that doesn't go in a specific section but does go in the ELF file are x terms. It's the only things. Things that don't go in the file at all and don't even get written to the symbol file are local variables. So any variable that gets defined in the function. So you can see in that main.c we've got the int result. That is a local variable. It gets defined within a function, it stays within a function. That's the only place you can call it. So it's not in the symbol file. Yeah?
So because x is defined globally but then messed around with in the main function, it goes in .bss and not .data?
The reason it goes in .bss instead of .data is because right now it doesn't have, like when we're first running through, it doesn't have a value.
Okay.
If the square function doesn't have extern, we just need square.
So square is a function. If it's an externs, no matter what there are functions, ints, anything, they always are undefined and don't get go into the section.
I'm sorry, yeah.
Yeah. Or yeah.
Yes, are the ones that aren't defined.
You guys can take your question. Yeah.
Did you say that things in .bss are undefined?
No,
Defined.
so they're not undefined. They're always defined. However, they're uninitialized.
Okay.
So that's the kind of distinction. Does everybody understand that distinction? Uninitialized versus, okay. So defined versus undefined. The only thing you're looking at there is whether it's an extern or not. That's the only classification for defined or undefined. If it's an extern, it is undefined. If it's not, it's defined. The way we can tell initialized versus uninitialized, so that .data versus the .bss section, is if it's assigned a value when you actually assign the variable name. So when you have that int x, and there's no value at the int x equals 5, since there's no like equals 5, it goes with the .bss section. If you look over at this function, that int I equals 5, that's going to go in the .data section because it's an initialized variable. Because it's given a value at the time it's created.
So then when it isn't given a value at the time it's created, then it goes into the .bss and it's uninitialized?
It's uninitialized, but it is defined.
Okay. But it goes in the .bss
Yeah.
in that case. Okay.
So with those rules, you should be able to like fill out all the questions for you now. Is there any other questions about this? Or on your cheat sheet? Your lecture slides first, and then yeah. knowing which sections go first. So in general, in a big ELF file, even in small ELF files, the ordering is always .text, then .data, then .bss. So when you combine the two, so when you combine main and squares ELF files, you're gonna stay in that same exact order. So .text, all the .texts, then all the .datas, then all the .bsses. The way you know which of main and square goes first in that ordering is we stay in the command line with that command ld-op main.o square.o. Since main is listed first, main's data is going to go first and all that. So if we're thinking about what the file is going to look like, it's going to be main's text, and then it's going to be squares text, and then main dot data, square dot data, mains dot bss, and squares dot bss. So this is what your file is going to look like. Remember that these two sections also don't consume any memory because there's actually no integers set there, no values.
That main square, main square test, main square test, root test,
Exactly.
and then,
Yeah. Yeah. So the question was if there are three files, and it would go main square, and then your third dot text, main square, then third dot data, and so on. Yeah.
So, if I was trying to access something from, say, square.bss, it would occupy the same memory location as means.bss?
Yeah. We're kind of just sitting there. Yeah.
So just to verify that, the general rule you used was just the order they showed up in that file plus section column, text first, and then data, then BSS frequent.
Yep. Exactly. Alright. So now we're actually gonna go and look and find like what memory address a variable is gonna go in. So we're looking for the address of x, which gets set in main. If we look back to our answers from part 3, we know that it gets set in the main.bss section. So we know we're looking for the memory address of this location right here. And we know we're given this address here. I think it's some long X number. Yeah. And then we know how big each of these 4 sections are. So what we're going to do now that we know it's here is we'll just add up these 4 sections, however long they are, convert that to hex, add that to this section. Algebra fun things. If you guys want me to do that addition, you guys can. I'm bad at addition on the board, so anyone who's in my recitation can attest. So we'll go ahead and skip that. Okay. Good to go. Any more questions about how you figure out where things are? Yeah.
So I just want to confirm that the address of X is going to actually be the address of main.bss.
Yeah. So it's going to be right after .data. Anything in BSS is going to be the address that's right after .data, since it doesn't take any memory space.
So all the variables share that address.
I'm sorry, only time.
So all the variables in the .bss share the same address.
Yeah. All the variables in .data or .bss share the same address. Yeah.
So I added all up to, and it equals 70, but would the main.bss, would it be at spot 74, or would it be at spot 70?
Spot 70. Yeah.
Like, say that we're given multiple variables, like a data, for instance, will the final test question give us, like, okay, find this variable even if it's like, say it's like an array with like both the size and both in data. We'll say like find array 1, which is like half
we know all of the general or how much space and how many bytes each data type takes up. So what you're going to do is look at the ordering for that. So if you've got an array and you're looking for the second array, if it's an array of ints, we know that's stored in 4 bytes. So you're going to add 4 to wherever the start of the array is to get that second element of the array. And kind of things like that. So just like looking at what's stored before it. If you're going to be in the middle of one of these sections, what's stored before it, and then adding your way. Knowing all the standard sizes. Yeah.
So if you have multiple variables in the .data or the .bss, is the order they're stored based on the order they appear?
Exactly. Yep. Order that variables are stored within like mains.data section are the order that they appear in that main.c file. Any other questions about that, guys? Alright. Question 5 is basically an extension of this guy. So, what addresses are going to be below and above different other addresses? So we go from low memory up here to high memory down here. So we can just kind of go and say, let's see, .data is, we know, is stored at a lower memory than .text. So we know answer 1 is wrong. We can kind of just keep doing that, knowing that this is our ordering. Yeah.
Sorry, so the question is not saying less than, is it?
So yeah, so that question is saying, if you take all of the addresses of where that would start in memory, which is less than another. So you know that these are.
Less than is like, oh.
Yeah, yeah. Because less than is up here, so least memory, so kind of before. Any questions on problem 5? Yeah.
So you said least memory.
Lowest memory address is at the top, and then higher memory addresses. So that's why we add the .data section. Yeah.
In order for the second statement to be right, would it have to say .bss squared equal .bss?
Yeah. So you flip the .bss for main and square. So even though they don't take up memory.
Right, so they would be equal though, right? Since they're at the same location? Or is it still like squared?
They're still ordered, so they'd be flipped. The variables themselves don't take up any space.
Okay, so
But the ordering is still technically flipped. Yeah. So that question again, if people didn't hear it. So in the second one, we've got .data of main and .bss of square and then .bss of main. So technically, even though the .bss section doesn't take up any room in any space in memory, the ordering is still flipped on that. So we will always have .bss of main before .bss of square. Because there's because of this ordering, even though they technically don't take up any room in memory.
Which was the final
Yes. Yeah.
Is there any scenario where BSS would take up any space, or does it always?
Those always. It would not be correct. So if we have for that second option, BSS squared equals .bss of main, that is not correct because there still is an ordering, even though technically there's no memory space taken up. Yeah.
What if X was initialized?
I'm sorry. What?
What if X had a value?
If X had a value, it'd be stored in main.data section.
So when you find the address, you would just add the .text, not the .data, right?
Yeah, exactly. Yeah.
So if it X did that value, we were asked to find X, we could be the straight up X. It is.
Yeah, so the question was if in question 4 when we're trying to find where X is stored in this file, X is going to be stored in main.data if it's initialized. So if it were initialized, it would be stored in main.data. So where would you go to find that? So you'd actually look right here, kind of at the start, assuming that it's the only variable initialized. And you're going to just add up the .text sections, and then that's where your variables can be stored.
But then as far as like since they're stored in .css, we didn't have to worry about any offsets.
Exactly, yeah. Since it is in a .bss, we don't have to worry about any offsets there. Yeah. Yeah. Yeah, so number 2 is wrong because of those last two equal signs. So the .bss is square and the .bss is main. So even though no memory is taken up, there's still a correct ordering to them. So they're technically flipped. Like we said here, we always store that main.bss and then that square.bss after. So. Alright. Unless anyone has any specific questions about number 6, I'm not going to address that because that's all from the linking PowerPoint, and I really, really want you guys to go and read through that PowerPoint. Because that's going to make all this a lot more clear and make the test go smoother, because obviously you've got 4 questions on this guy. There's a good chance we're going to focus a lot on linking on the actual exam. Yeah?
I guess my question is, why would a file need to be dynamically linked, or like have to be dynamically linked?
Yeah. So if you look at, so the question is, why does a file need to be dynamically linked? The reason is here. So if we look at the main.c and square.c, we see that main actually calls that function square. So one reason we need it is because in main, that square function isn't defined. So we need some way of telling main.c that yes, square is defined, go and look in this file for it. So that's kind of how we do it with the linker. The other thing that a linker does is it enables you to edit one file and not have to recompile every other file. You can just relink.
So why is that not statically linked then? Like why is that considered dynamically linked?
So the dynamic linking is like I said, you don't need to compile all of the files again. You only need to recompile the files that have been changed and then relink all of them. That one is statically linked.
So the answer is no.
File must be done. Oh, okay, I see what you're saying. Yeah. So that's the reason that we would do it. Like they're saying, it doesn't have to